अस्सलाम वालेकुम। आई एम ASAD ज़हीर और आज हम 9वीं क्लास के टॉपिक शील्डिंग इफेक्ट के बारे में डिस्कस करेंगे। आज हम डिस्कस करेंगे कि शील्डिंग इफेक्ट क्या होता है। देन हम डिस्कस करेंगे कि एटॉमिक स्ट्रक्चर की बेस पे हम शील्डिंग इफेक्ट को कैसे डिस्क्राइब करेंगे। थर्ड थर्ड हम डिस्कस करेंगे कि शील्डिंग इफेक्ट जो है इसका पीरियोडिक टेबल में ग्रुप एंड पीरियड्स में क्या ट्रेंड्स है, मींस ये ग्रुप एंड पीरियड्स में कैसे चेंज होता है। और फोर्थ नंबर पर हम डिस्कस करेंगे कि हम डिफरेंट एग्जांपल्स में शील्डिंग इफेक्ट को कैसे फाइंड कर सकते हैं। एंड फिफ्थ हम इसकी एज असाइनमेंट सॉल्व करेंगे। सो लेट्स स्टार्ट। फर्स्ट ऑफ ऑल हम शील्डिंग इफेक्ट के बारे में डिस्कस करते हैं कि एक्चुअल में शील्डिंग इफेक्ट है क्या। तो कहते हैं दी रिडक्शन इन द फोर्स of attraction between the nucleus and valence shell electrons by the presence of electrons in inner subshells is called shielding effect. It's mean that this definition described as the reduction in the force of attraction, means when the reduction in the force of attraction take place in between the nucleus and valence shell electrons, means जब वैलेंस शेल में जो इलेक्ट्रॉन, जिसे हम आउटर मोस्ट शेल भी कहते हैं, अगर उसमें जो इलेक्ट्रॉन्स हैं उन इलेक्ट्रॉन्स और न्यूक्लियस के दरमियान जो फोर्स ऑफ अट्रैक्शन है जब वो कम होती है तो उसके कम होने को हम लोग क्या बोलते हैं, शील्डिंग इफेक्ट बोलते हैं। अब यहाँ पे रीजन ये है कि वो कम क्यों होती है, तो ये उसने आपको इसकी रीजन यहाँ पे डिस्क्राइब कर दिया है। उसने कहा है बाय द प्रेजेंस ऑफ इलेक्ट्रॉन्स इन द इनर सब शेल, मींस जो सबसे लास्ट वाला शेल है उसमें मौजूद इलेक्ट्रॉन्स और न्यूक्लियस के दरमियान जो फोर्स ऑफ अट्रैक्शन है जब वो कम हो जाती है उसे हम क्या बोलते हैं, शील्डिंग इफेक्ट बोलते हैं। अब वो कम क्यों होती है, वो इसलिए कम होती है कि जब एटम का जो सबसे बाहर वाला शेल है उसके अलावा जो अंदर वाले शेल्स होते हैं उनमें जो इलेक्ट्रॉन्स होते हैं, इनर शेल में जो इलेक्ट्रॉन्स होते हैं वो क्या करते हैं, इस फोर्स ऑफ अट्रैक्शन को रिड्यूस कर देते हैं, मतलब कि रिडक्शन का बायस बनते हैं। तो अभी हम देखते हैं कि ये जो हमने ये डेफिनेशन यहाँ डिस्क्राइब की है इसको हम एटॉमिक स्ट्रक्चर्स की बेस पे यहाँ पे डिस्क्राइब करते हैं। तो सबसे पहले हम देखेंगे ये हमारे पास इसकी क्या थी डेफिनेशन। सेकंड हम लोग बात करते हैं एक्सप्लेनेशन बाय यूजिंग द एटॉमिक स्ट्रक्चर। हम लोग देखेंगे कि एटॉमिक स्ट्रक्चर की बेस पे हम लोग शील्डिंग इफेक्ट को कैसे डिस्क्राइब करते हैं। सो लेट्स स्टार्ट। वी नो दैट in the periodic table there are two categories. One is called group and second is called period. And we know that from when we move from top to bottom in the periodic table, that is called group. And when we move from left to right in the periodic tables, the arrangement of elements is called period. So let's suppose we are draw the first group like hydrogen, lithium, sodium. Here I am described the three elements like hydrogen, lithium and sodium. And we discussed that the atomic number of hydrogen is 1, lithium is 3 and sodium is 11. So draw the structure of hydrogen atom. We know that in the center there is a nucleus and the hydrogen has only one electron, so we draw the electron in the first shell. Because it has only one electron, so it has only one shell. Second, we describe the atomic structure of lithium. lithium has two electrons in one shell, first shell, and in the last shell it has only one electrons. When we describe the structure of sodium, we draw that we draw two electrons in the first shell, eight electrons in the second shell, and one electron in the last shell. Here we are see that the number of shells are increasing when we move from top to bottom in the periodic table, because this is group 1A. So the first element is hydrogen. It has only one electron in the first shell. In the second element, that is called lithium, it has two shells, one and first and second. In the first shell, it has two electrons, and the second shell, it has one electrons. When we move to sodium, it has one electron in first shell, eight electrons in the second shell, and one electron in the last shell. It's mean that when we move from top to bottom, the number of shells are increasing. Like it has only one shell, it has two shell, and it has three shell. So we have represented the number of shell by the small letter n. So here we know that n is equal to 1. It's mean that it has only one shell. When we write down the n is equal to 2, it's mean it has two shells and it has three shells. Now we are discuss about the period. If I use the second period, because hydrogen to helium is first period, and I am draw the second period of the periodic table. So in the second period, the first element is lithium, second element is beryllium, third element is boron, and fourth element is carbon. So we can draw the structure, atomic structure of these elements. Here I am drawing the structure of beryllium. It has two electrons in the first shell. Here it has two electrons in the second shell. In the boron, two electrons in the first shell and three electrons are present in the third shell. Here two electrons are in the first shell and four electrons are present in the fourth shell. So when we move from left to right in the periodic table, the number of shells are constant. Like in the lithium has two shells, in the beryllium has two shells, in the boron has two shells, in the carbon has two shells. But the number of electrons are increasing. So we can see that when we move top to bottom in the group, the number of shells are increasing continuously. 1, 2, 3. But we move from left to right in the period of the periodic table, the number of shells are remain constant. So we can see that number of shells are remain constant. Here, the last shell is called valence shell. Here, this is called valence shell. This is called valence shell. This is called valence shell. So inside the valence shells, only one shell are present in all of these elements, all of these atoms. So we can see that the number of electrons in the inner shell is 2, inner shell is 2, inner shell is 2, inner shell is 2. So we describe that in the period, number of shells are constant, point number 1. Point number 2, the number of electrons in the inner shell. So here only one inner shell is present, so it has only two electrons. It has only two electrons and two electrons. So number of electrons in the inner subshells are constant. Okay. When we describe the nature of the shielding effect in the group, we see that when we move from top to bottom in the group, number of shells are increasing. Number of shells are increasing because hydrogen has only one shell. lithium has two shells, sodium has three shells, and so on. So second condition is that here in the hydrogen there is no inner shells are present. But in lithium, one inner shells are present that contain the two electrons. But in sodium, two inner shells are present that contain the 2 and 8, 10 electrons. Means when we move from top to bottom, the inner shells are increasing. When the inner shells are increasing, the number of electrons are also increasing. So, number of electrons in inner subshells are increasing. So, by using the atomic structure, we are describe the nature of the shielding effect in the group and period. So, we can see that in the group from top to bottom, the shielding effect are increasing because when the number of here, I discussed that when we move from top to from nucleus to the outermost electrons in the solar lithium, and when we move from nucleus to the last valence shell electron in the sodium, the distance between nucleus and the valence electron is in lithium is less as compared to sodium. We know that when the distance are increasing, it means that the reduction in force of attraction is decreasing because large distance is directly relation to shielding effect. So we can say that when the distance are increasing, the force of attraction are decreasing. So the reduction in the force of attraction is called shielding effect. When the distance between the nucleus and the valence electrons are increasing, distance are increasing, shielding effect also increasing because reduction in the force of attraction is also called shielding effect. So next we are discuss we are discuss about trends. Trends mean the nature of shielding effect in the group and periods. Here we are discussed with the help of diagrams, atomic structures. Where here we are with proper elaboration. First of all, we are discussed in group. Here we are discussed that in the group from top to bottom, the shielding effect is increasing. So we say that in groups from top to bottom, this shielding effect is increasing. So now we are write down the reason about this statement. So first reason is that we have discussed here that the number of shells are increasing. So we can say that the number of inner shells are increasing because here there is no inner shell is present. Here one inner shell is present. Here two inner shell is present. So from top to bottom the number of inner shells are increasing. Second is the number of electrons in inner subshells are increasing. So why we are write down the term subshells? In the previous topics, we had discussed about electronic configuration. we are know that in each shell, the subshells are also present that are called S, P, D, and F. So when the number of shells are increasing, the subshell are also increasing. So here we are write down the term subshell. It means that subshell is the smallest part of the shell. So first of all, electrons are filled in the subshells. Then these subshells are combined to form a complete shell. So when we fill the electrons, we are using the term subshell instead of shell. So next in the group, and now we are discussing in the in period. In period, we are know that from left to right in the periodic table, the number of inner shell are constant. The number of electrons in the inner shell are also constant. So we can say that the shielding effect is remain the constant in the periodic table. A period of the periodic table. So we can that in period from left to right, the shielding effect is remain constant. The reason is that the number of inner shells are constant, and the second reason is that the number of electrons in inner subshells are constant. So this is the topic related to the shielding effect. Here we are discuss about the definition of the shielding effect. We are describing the shielding effect with the help of atomic structure in the group and period of the periodic table. And here we are discuss about the trends of the elements of the shielding effect in group and period in the proper way. So this is a description and this is a conclusion of this description. So now we are discuss about the example of the shielding effect. Let's identify the shielding, identify the greater shielding effect in the given examples. Like we can describe the example here oxygen and nitrogen. B we are describe fluorine and chlorine. Okay, first of all we're taking the example oxygen and nitrogen. Example number A, oxygen and nitrogen. When you find this type of example in your exam, it is the easy way to find the shielding fact in these elements. First of all, describe the atomic structure. Atomic structure means we are describing these examples will be solved in two methods. We are using any method from this. Like we know that the atomic structure of oxygen is 8 and nitrogen is 7. Draw the atomic structure. In oxygen, first shell has 2 electrons, second shell has 6 electrons. In nitrogen, first shell has 2 electrons and second shell has 5 electrons. So, In the oxygen, there are only two shells. So n is equal to 2. Here n is equal to 2. When the number of shells are equal, so it means that they are belong to the same period, because number of shells are describing the term period of the periodic table. So here we have discussed that the number of inner shells are constant. So here only one inner shell is present. Here is only one inner shell is present. When the number of shells are same, it's mean that these two elements are belong to the same period. So now when we find the number of period is constant, we are simply describe the reason and statement of the periodic table here. So we can say that in the period from left to right, the shielding effect is the main constant. So in oxygen and nitrogen, the shielding effect is constant, because both these elements are belong to the same period, because they have equal number of shells. So then we can write these two reasons below the this statement. Like in oxygen and nitrogen, the shielding effect is constant. Reason, due to constant number of shells, due to constant number of electrons in inner subshell. Means that when we find that the number of shells are constant, it means that about we are discussing about the period of the periodic table. When the number of shells are not constant, it means that we are discuss about the group. For example, in the fluorine and chlorine, fluorine has atomic number 9 and chlorine has 17. So we can describe this term by using the atomic structure like that. In the fluorine, two electrons are present in the first shell and the seven electrons are present in the second shell. In the chlorine, two electrons are present in the first shell and eight electrons are present in the second shell, and 7 electrons are present in the last shell. So we can see that here is the number of shells are 2 and here is the number of shells are 3. So the number of shells are different. So it's mean that we are discussing about the group of the periodic table. So you can see that when we move from top to bottom in the group of the periodic table, the number of shells are increasing. When the number of shells are increasing, the distance between the nucleus and the valence electrons are increasing. So greater the distance mean the higher the shielding effect. It means that chlorine has greater shielding effect than fluorine. So we can see that chlorine has greater shielding effect than fluorine, and we can write these reason here. Like same that oxygen and nitrogen have equal number of shielding effect. You can write the oxygen is equal to nitrogen because both have same number of shells. So now we are taking an assignment. You will solve this assignment. You will solve this assignment, and after solving this assignment, you will comment this assignment in the you will send this solved assignment in the comment section. We will find it and mark it and will reply you as soon as possible. Like Identify identify the shielding effect in the given examples. In the given pair of atoms as example. For example, you will solve the silicon and phosphorus, magnesium and calcium, and oxygen and fluorine. You will solve these questions according to this question and send it in the comment section, and we will find it and mark it and will respond you as soon as possible. Or you can send these solved questions on this given number that are mentioned in this video, and we will respond you as soon as possible.